All right, today we're going to talk about something you've definitely heard of, but maybe sounds a little intimidating. The Matrix. And no, not the movie. This is about something that powers pretty much everything, from your computer screen to huge business decisions. It might sound like crazy sci-fi stuff, but you're about to see it's actually a super simple and super powerful way to organize information, so let's dive right in.
Okay, so let's kick things off with a question. Look at this smiling face. You and I see it, no problem. But how does a computer see it? I mean, it doesn't have eyes, right? So how in the world does it process this image? Well, the answer is actually pretty clever.
The secret? It uses a secret code. It's a code made completely out of numbers. This numerical language is basically how computers talk about images. It's how they understand and mess with not just this little drawing, but literally every single picture you've ever seen on a screen. All right, Section 1, what computers see. So let's pull back the curtain and take a look at this secret code, shall we? And there it is. This grid of zeros and ones, that is the smiley face, just in computer speak. A 1 basically means turn this pixel on, and a 0 means leave it off. And just like that, a picture becomes data. This awesome organized grid of numbers, well, that's our very first look at a matrix.
Now, this is the really important part to get. For the computer, this grid of numbers is the image. It's not a translation, it's the thing itself. So if you wanted to say, create a negative of this image, the computer just flips all the zeros to ones and all the ones to zeros. That's it. It's all just playing with numbers.
Okay, Section 2, Anatomy of a Matrix. So we've seen one out in the wild. Now let's get a little more formal and break down what exactly a matrix is.
So, at its core, what is a matrix? It's really just a rectangular box of numbers. That's it. Its whole job is to store information in a way that's super effective and efficient. The key things to remember are rectangular and organized.
Okay, let's step away from pixels for a second and talk about pastries. Here's a perfect real-world example. This matrix is showing us the sales data for Kate's Bakeries. You've got 3 different bakeries, right? Each row is one of those locations, and the columns tell us what they sold, bagels and muffins. See how clean that is? It's simple, but it's packed with info.
And here's the absolute key to understanding matrices. The location of a number is just as important as the number itself. Think about it. If I just said the number 127, it means nothing, right? But in this matrix, because it's in row 2 and column 2, we know exactly what it means. 127 muffins sold at bakery number 2. The grid, the structure itself, is what gives the numbers their meaning.
Now, every matrix has a specific size, and we call that its order. And figuring it out is super easy. You just follow 3 simple steps. First, you count the number of rows, the ones that go across. Second, count the columns, the ones that go up and down. And third, you just write it out as rows by columns.
So, if we hop back to Kate's Bakeries, let's see. It's got 3 rows, 1 for each shop, and it's got 2 columns, 1 for bagels and 1 for muffins. So we'd say this is a 3 by 2 matrix. Simple as that. All right, Section 3, from pixels to pastries. Now let's really get into why organizing data like this is so powerful. It doesn't matter if it's pixels or pastries. The magic is in how you can find insights fast.
Okay, because all this data is laid out so neatly, we can do some really quick math. If you just add up the numbers in each row, you get the total items sold at each bakery. And wow, look at that. The results are pretty clear, aren't they? Location 3 is, well, it's really lagging behind the others. And this is what makes matrices so amazing. Kate doesn't have to go digging through a huge messy pile of receipts or a complicated spreadsheet. She can just look at this simple little grid of 6 numbers, and bam, the problem is right there. Location 3 is seriously underperforming. The structure of the matrix makes the important stuff just jump right out at you.
Okay, Section 4, a gallery of matrices. Believe it or not all matrices are the same. So let's take a quick little tour of a few special types you might run into, each with its own cool properties. First up, we have the square matrix. This one's pretty straightforward. It just means it has the exact same number of rows as columns, so it looks like a square. And a really cool type of square matrix is the symmetric matrix. This one's special because it's like a perfect mirror image of itself across the main diagonal that runs from the top left to the bottom right.
Here, check this out. See that main diagonal going down the middle, the 5, 6, and 1? Now look at the numbers on either side of it. You see how the 2s are mirrored? And the 3s? And the 7s? It's a perfect reflection. Pretty neat, right?
Next up, we have the identity matrix. This is another type of square matrix, but its rule is simple.
It has ones all down the main diagonal and zeros absolutely everywhere else. This one is super important for doing calculations with matrices. Then there's the lower triangular matrix. For this one, every number above the main diagonal has to be a 0. These are really useful for making complicated problems a lot simpler to solve.
And here's a classic example of a 3x3 identity matrix. See that perfect line of ones with zeros all around it? A really good way to think about this is that the identity matrix is kind of like the number 1 in regular math. You know how multiplying by 1 doesn't change anything? This matrix has a similar special role, which makes it a total cornerstone in more advanced stuff.
Okay, our final section, the power of organization. Let's bring this all together. At the end of the day, whether we're talking about pixels or pastries, it all boils down to one simple but powerful idea: organization.
So why should you care about any of this? Well, here's the bottom line. Matrices are basically the language computers use to juggle enormous amounts of data. They take complicated information and lay it out so clearly that we can spot patterns in a blink of an eye. They're the absolute foundation for so many things we use every day, like computer graphics, artificial intelligence, and all of modern data science.
So, I'll leave you with a little puzzle to think about. Imagine you have a grid of numbers. The first row has 2 numbers in it, but the second row only has 1. Now, based on what we talked about, that core rule that a matrix has to be a rectangular grid, do you think that would count as a matrix? It's a simple question, but the answer really gets to the heart of what makes this whole concept work. Thanks for tuning in.